All right. Hello, everybody. Welcome to the SANS Cloud Security Forum. I'm very excited for you guys, for everybody right now, because this is our very first Cloud Security Forum. And yes, let me go ahead and start my video. Thank you very much. Appreciate that. And this is the very first Cloud Security Solutions Forum that SANS and AWS Marketplace are doing together. Very excited for today because we've got 7 great talks lined up. We've got speakers both from the SANS Institute and from AWS covering a wide variety of topics. Now, before we get into the material itself, I do want to mention one logistical item is that there is a Slack workspace. You should have all received an invitation to join the Slack workspace. The link will be shared in the Zoom chat again as well. But when you get a chance, please do go ahead and join that Slack workspace because we've got channels there for all of the speakers to chat with everybody, catch up with everybody in our virtual hallways, if you will. Now, with that, I'm going to go ahead and just dive into the material here. In terms of the first talk today, I will be sharing with you guys some three items that I think are really important to be successful from a cloud security perspective in your organizations. So just a very quick introduction. I'm Frank Kim. I've been teaching and writing classes with SANS for a long time, have my own consulting practice and currently lead both of our management and our cloud security curricula here at SANS. Feel free to go ahead and drop me a line here in email, on Twitter, on LinkedIn. Go ahead and you can go ahead and hassle me here online as well. You know, if you do that during the session here itself, I won't see it until a little bit afterwards, but you know, that's how to get in touch with me. In terms of the 3 things that I would like to share with you guys today, they're really just kind of 3 core foundational elements. Number 1 is talking a little bit about identity. Number 2 is talking a little bit about monitoring. And then finally, the last topic that I will share with you guys is a little bit of information about automation. So with that, let's go ahead and dive right into it. So number 1, from an identity perspective, I think we all understand that IAM, identity and access management, which some other speakers will be talking about in as well, is a very big, very broad topic. So in the limited time that we have in this particular talk, I just want to share one particular item related to identity. But before we get into all of those details, we do need to set the stage here a little bit in terms of, well, what's our simple architecture that we want to keep in mind? And certainly in this diagram here on the right-hand side, we've got our various resources in AWS Cloud, various services that we're utilizing. We've got a VPC, a virtual private cloud. We've got inside of that VPC, a public subnet. And inside of that public subnet, of course, we've got our cloud virtual machine, our EC2 instance, where we are hosting our application functionality. But from an identity perspective, we, of course, interact with AWS IAM. Under the hood, we interact with STS, Secure Token Service, to get some temporary credentials to give back to our application running on EC2 so that it can access some information that it needs, some user data, some customer data that might be stored in Amazon S3 in this particular example. Now, on the next slide here, just by virtue of the fact that we are utilizing these various services, we have available to us different security controls that we can implement. We just want to remind ourselves what these basic foundational items are here to start with in our simple architecture. We've got security controls associated with our VPC and corresponding subnet configurations. We've got number 2, our network access control lists that are associated with the corresponding subnet. Similarly, we've got our security group, our stateful firewall associated with our EC2 instances, and the various permissions that we would define in IAM to access things like S3 and other AWS services. So with that out of the way, here on the next slide, the one thing related to identity that I would like to share here in our short time together is a little bit of information about the AWS instance profile. Now, the instance profile, on the prior slide, I mentioned that your EC2 instance running your application functionality, well, it'll interact with IAM, interact with STS, and go about getting some temporary credentials so that it could have the appropriate access to get data from places like S3 and from other S3 services. In the olden days, and I've worked on applications where I've done this many years ago, is I would hard code in some form or fashion the credentials to access my application services like S3 directly in the application on my virtual machine. That's not such a great practice. Fortunately, AWS provides this functionality that we see here in terms of the Instance Metadata Service, IMDS, that is accessible as we see here at this IP address at the top in line number 1. Now, when we access this particular URL, the Instance Metadata Service, we will get a response. Under the hood, we get a response saying what is the corresponding access key ID, what's the corresponding secret access key, and so on, that gives our instance specific permissions to access S3 in our simple architecture example. Now, the reason that I mentioned this to remind ourselves to set the stage is, well, I think we're probably all familiar with the Capital One data breach. Now, organizations have been breached in the past. There's going to be breaches in the future. This is not to, of course, pick on Capital One, but the thing that I found most interesting about this particular breach is that, well, when it came to light in July of last year, well, there was a FBI affidavit that was filed that contained a number of interesting technical details associated with the attack. What were some names of some potential roles that were associated with this attack? How did the attacker go about conducting, right, and stealing this data in particular? And so this Capital One breach is a very illustrative lesson about the types of things that we want to consider, even though we've got some of those controls, security controls, perhaps already in place, as we discussed in our simple architecture. Now, that being said, going back to our architecture itself, what is it that the attacker did? On the left-hand side here in step number 1, well, the attacker discovered an application that was vulnerable to SSRF. We'll talk about that more in just a moment. They accessed the application, discover a SSRF vulnerability that then allowed them to call that URL that we just saw on a previous slide, the Instance Metadata Service, and steal the temporary credentials, getting them back on the attacker's machine wherever they were in the world connected to the internet, then used those same credentials to connect directly to the S3 bucket and download data. Well, with that in place, let's go ahead and understand a little bit more about what actually occurred here. Now, very quickly, SSRF occurs when, well, an application requests some data. And when they request this data, it's actually coming from a different URL. Normally, attackers, normal users might go ahead and access your example application using some URL like this that has a normal request here connecting to some API, talking to some API endpoint. But the malicious request down here at the bottom, instead the attacker, as you can see, has replaced the target URL with the IP address for the internal instance metadata service. And this is then what allows the attacker to, here on the next slide, leverage the actual permissions that were defined in a role, perhaps looking something like this. And one thing that was interesting in the FBI affidavit that it called out was that, hey, there was some sort of WAF role that was used. The FBI affidavit actually called it the *** WAF role. I've named it here bad WAF role just for illustration purposes. And the part about this that was bad was that we can presume that the role allowed access to any resource down here. And that's the corresponding permissions that were associated with the credentials that were sent back via that SSRF attack. Here on the next slide, by calling this particular URL with the corresponding target URL, attacker will go ahead and get the application response containing those access keys, secret access key IDs, which would then allow them to simply run AWS configure from their machine and connect to the backend S3 bucket as with the same permissions that the application had, allowing them to simply run a S3 sync type of command to download, well, the contents in that particular S3 bucket. So the last slide here from an identity perspective, it's important to understand, well, what do we need to configure? What permissions do we need to grant? It's also important to understand how under the hood, some of these things are actually working to mitigate some of these common attacks. Now, certainly with the shared responsibility model, well, we, the application owners, we, the users of the cloud, well, we've got to think about how do we prevent SSRF vulnerabilities, make sure we don't have those issues in our code. How do we configure our roles appropriately with the appropriate permissions, restricting access? But hey, AWS also went on to say, look, there's some things that we as the cloud provider could potentially provide as well. So this is where they came up with V2 version 2 of the instance metadata service. One, it requires use of a session token. Now, instead of just being able to connect to the IP address associated with the instance metadata service, well, now in version 2, you've got to first get a token, use that token then on line number 4 to actually successfully call the instance metadata service. And oh, by the way, when you are making this call with a particular token, usage of this token is limited. 6-hour maximum time limit, that's also configurable, but it can only be used from the instance where the session began. That's pretty cool. And oh, by the way, by default, it can't travel beyond the instance itself because the network packet TTL has been set to 1. And there's another protection here to prevent bad requests if you've got open proxies, open WAFs, preventing the X forwarded for header. If there's an X forwarded for header, right, you're going to go ahead and block, right, that request in version 2. So from an identity perspective, number of things, just one example of some of the things that we want to watch out for here. All right, now I'm going to very quickly mention monitoring here in the short time that we have. And from a monitoring perspective, if we think about this attack, well, the good news is that a lot of this activity is already logged, whether it be IAM activity, STS activity, right? Using your CloudTrail logs, you can go ahead and look for activity like the assume role call to see where these roles might be being assumed. Some of that activity is actually taking place. And of course, well, what in this particular example, what did the attacker do? They wanted to steal data, exfiltrate data, and they sent a bunch of requests, downloaded a bunch of data from S3. Well, to monitor that, we've got both your server access logs, data about requests made to a particular bucket, but you've got also object level logging that could be enabled that would allow you to identify actions like list bucket, get objects, and so on that would have potentially helped you identify this malicious activity. Well, you know, in AWS itself, there's some other cool stuff. Guard Duty, right? Guard Duty, the threat detection service from AWS, has a couple of finding types. Here, you see the first one, unauthorized access. Well, this is where you've got instance credential exfiltration. Does that sound familiar, using STS, stealing those temporary credentials? Well, now there's a possibility of having this automatically detected for you. Same thing here with your S3, bucket enumeration and your get objects calls. If there is unusual activity, this could potentially be detected. Finally, we've got a CloudWatch metric. Now, many of us are still using the version 1 of the instance metadata service, but we can go ahead and monitor usage for that when we slowly migrate away from using version 1, we can see the number of times that the metadata service was successfully accessed without a token using version 1. And if we've got metadata no token, when it goes down to 0, well, then now we know, we've got a sense of, okay, now we can successfully migrate all of our applications. Now, the last thing that I want to mention here is automation. And we're going to be switching examples here a little bit, right? We're going to use a slightly different example. And there's one open source tool that I want to highlight here, which is Cloud Custodian. Now, this is a free open source tool actually created originally from the folks at Capital One, Kapil Thengavelu. He originally created Cloud Custodian. And there's a number of cool things that this open source tool can help you detect. Root logins, bad configurations, and so on. One example here that I want to highlight for the rest of these slides is the last one here in terms of detecting and remediating security group violations. Now, this is just an example of the Cloud Custodian policy file, one policy file that you could potentially deploy. And what we've got highlighted here is just showing that this is the policy for remediating, well, bad security groups. And whenever there is a call, a CloudTrail log that's been generated with authorized security group ingress or egress or revoking these corresponding configurations, well, you can see that if it is setting access from a 0.0.0 anywhere in the world, well, Cloud Custodian is going to, in this example policy, go ahead and automatically remove the permission, right? So how does this actually work? Well, we've mentioned CloudTrail already a couple of times. This is your basic remediation workflow. We know that all AWS APIs, they generate CloudTrail logs. Well, when these CloudTrail logs are generated, you can also go ahead and use CloudWatch, corresponding event rule, corresponding target trigger, to go ahead and trigger a Lambda function. And it's this Lambda function that has some additional capabilities to automatically remediate those violations. And so why is this important? Let's pretend that you, in your organization, have a Bastion security group. You've got a Bastion server defined where people should only be able to SSH into the Bastion server to then do some administrative activities. Well, you can see down here below, somebody has accidentally misconfigured this security group to allow both port 80 and port 443 access from anywhere in the world, kind of violating, right, the whole idea of having the Bastion host only have SSH enabled. You're not going to deploy a web server on this particular Bastion per your various requirements. So if that actually occurs, well, somebody made that misconfiguration. This is an example of the CloudTrail log where security group ingress has been authorized, the corresponding security group ID. And we know that this is not what we want because it is down at the bottom, allowing access from anywhere. We've also got the CloudWatch event rule that has been generated, right? That has been created for you by that Cloud Custodian functionality that has been deployed. And here on the next slide, when this event actually occurs, you've got a CloudWatch event log that says, okay, we've detected authorized security group ingress, change in configuration for this particular security group, allowing access from everywhere. But down here in the lower right, let's go ahead now and remove the corresponding permissions. Now, when you go ahead and invoke that, you can see here on the next slide that Cloud Custodian has been configured to deploy, to call, to trigger this high-risk security group remediate Lambda function right here. Now, when this function is actually called, this is just what the function looks like here. And when the function is called, well, very quickly, in a matter of actually seconds, you can see that the bad rules that violate our business requirements have been automatically deleted, only allowing access on port 22 via this Bastion security group here. And so that was just a little bit here about, to summarize, right? We just talked about identity, showed you an example of the instance metadata service, how that's used, how that could potentially be exploited by SSRF, some of the new features, functionality that has been added to the instance metadata service version 2. We talked a little bit about monitoring and what you could do to go ahead and monitor for this type of activity, even leveraging some AWS services. And then finally, we talked about, okay, well, in certain cases, what's an example of how you can go about automating? And when I talk to various customers, when I talk to various students, these are some of the 3 of the most important things in terms of identity, monitoring, and corresponding automation that you want to think about in terms of improving your cloud security capabilities. Now, on the very last slide here, one other thing that reminder is, at the beginning of this session, I mentioned that this Cloud Security Solutions Forum, right, jointly done by SANS and AWS Marketplace. Now, AWS Marketplace has also sponsored this free cloud security book here. If I remember correctly, this book is crazy. There are 365 pages of material in this book, freely available at the link down here at the very bottom of the slide. Highly recommend you check this out. Now, with that,